Hello, this is Mr. Stewart. You are watching this quiz. If you're watching this video, it's because you either are just reviewing before you take the 2.1 quiz, Intro to Rational Numbers, or you've already taken it and didn't pass it, and so now you're just looking for a little extra help. Either way, let's dive right into it. You're going to notice there's actually 6 questions on this quiz instead of the traditional 5. Many of these questions we're not going to be able to answer even with a second made-up question. So what I'm going to do is just going to talk to you guys about this. This reads, name the word that matches the definition given. So a decimal that has a pattern that repeats. Honestly, I feel like the answer is in the question itself, but if you're not sure what the definition of a decimal that repeats is called, maybe just make your best guess or use logical skills, but we will be putting a video. I'll just put a video link right here, and that'll hopefully maybe you can sit and watch that and just learn about that one, and we'll just move on to the next one. Okay, question 2, again, another definition question. So this is more just recalling what you learned when we taught this in class. You may probably want to refer to your notes, but a decimal, says match the word, a decimal that ends. A decimal that ends. Okay, so that's different than a decimal that's repeating. This is now called a decimal that ends. And so you're gonna see examples like this. And here, by the way, I'll give you an example. I'll just do this. 1/4. If you were to convert this to a decimal, this would come out as 25/100ths. Think about 1/4 of a dollar would be 25 cents, so that makes sense. This would be an example of a decimal that is ending. It's a decimal number, it's a rational number with a decimal that does not continue. It ended. It's done. There's nothing else. But what if I did something like this, 1.3, I'm sorry, 1/3? Well, in this case, if you were to type this in your calculator, this would be a decimal that never ends, that continues repeating. So this would be 1/3 would be the same as 0.33333333333, and by the way, it's never going to end. What this is doing, long division, by the way, is it's saying, well, how many times does 3 go into 1? So it starts here and it goes, okay, 3 goes into 10 3 times perfectly. 3 times 3 is 9. With 1 left over, bring down to 0. 3 goes into 10. And you can see that this pattern is going to continue on and on and on. So the decimal form is trying to give us the same thing as 1/3, and it can't quite ever get there. It's trying its best, but it's just going to keep going on and on and on. So this is an example of a decimal that's not ending versus a decimal that finishes, it's done, it's finished. Okay, and so as you're looking at these two examples, this may help you remember the definitions. But again, watch another video about decimals that end here, and maybe that'll be helpful for you. Alright, so this is asking you to write a decimal in fraction form. So rational numbers, there's many different ways to write rational numbers. You got to remember, first of all, that every whole number is also a rational number. So for example, if I said 8, this is the same as 8/1. It's also the same thing as 8.0. So this integer is also a rational number, and here's a decimal form rational, and here's a fraction form rational, but it's all the same. So we can go from decimals to fractions, and we can go from fractions to decimals in form notation. In this case, we're given a decimal, and it's asking us to write the fraction that represents this decimal. And oftentimes, it's going to ask you to reduce. It says, let's see, in simplest form, that means to reduce. So like, for example, if I did 5/10, this wouldn't be what we would call simplest form. We would want to reduce this to 1/2, which is 1/2. So that's what we're talking about when we say reduce. So here we go. Let's make one up, and I'll just do a negative. I don't know, 0.4. I'll write it like this. So a negative 0.4. Okay. So what I like to think of is place value. If I can say this word out loud using the place value, instead of saying 0.4, instead of saying that, if I said 0 and 4 place value and 4 tenths like this. If I said 0 and 4 tenths, this actually tells me how to write this in a fraction. 4 tenths, if you say 4 tenths, well, that just sounds like 4 tenths. Isn't that true? So, and by the way, it's a negative. So it's a negative 0 and 4 tenths. Well, 4 tenths and so a negative 4 tenths and a negative 4 tenths is the same thing. I would say in decimal form, this is 4 tenths. In fraction form, I'd say this is 4 tenths. Now all I need to do is reduce this. So this is going to be a negative, let's see, 2 goes into 10 evenly, and 2 goes into 4 evenly. So I'm going to reduce this by 2's. So 2 goes into 4 twice. 2 goes into 10 5 times. And I think this is my simplest form, so a negative 2/5. You'll want to evaluate your own over here and see if you can figure out the most simplified form. Don't forget, it is still a negative. Okay, alright, so order the numbers from least to greatest. Again, this might be something that's going to be hard to simulate or hard to show an example of, but you've got numbers here, and what this is saying is, a good way to think of this is, let's say this is on a number line. So there's 0. If you were to look at each one of these values, so a negative 7/8, a positive 7/9, 1.3, a negative 8/3, and a 0.4, if you were to look at these and then place them on the number line, which one's going to be farthest to the left, which one's going to be farthest to the right, and in what order do the rest of them come? If you're able to put these correctly on the number line, then this is going to be in order from least to greatest. So my advice to you with this one, I don't think I'll make one up and solve it. I think what I'll do is I'll just say my advice to you is to put each number in the same form. If you can do that, if you can put each number in the same form, then it's going to be easier to compare. A lot of students struggle with saying, okay, what's bigger, 7/9 or 1.3 or 0.4, or what's farther away from 0? It's hard to visualize because they're all in different forms. But let's say, and by the way, personally, this is just my personal opinion, I like using the decimal form. Decimal forms for me are easier to compare. Don't ask me why, I just do. Okay? So you got to think, first of all, these two are negative, they're the only two negatives. So you better at least put these two on this side. So one of these two has to be first. The other three are positive, so those three are going to be over here somewhere. Okay? So none of these numbers are going to be the largest number. These two numbers will not be the largest. It's going to be one of these three. Okay? So that's important. You kind of using logic to be able to figure this out. Now honestly, I would just convert each one of these to a decimal. And remember, fractions can be easily converted to a decimal just using a calculator, just using division. 7/8 or a negative 7/8 is the same thing as saying 7 divided by 8. This is going to give you a decimal. I mean, I'll even do this one on the calculator. I'll just say, okay, 7 divided by 8, 7, I'm just typing in my calculator right now. This gives me a 0.875. 5, and don't forget it's still a negative, so we just keep that in the negative. Now this is going to be easier to compare to this number here than as if it were in fractions, so 3/8. And that's just one of those things. So I would convert each one of these to a decimal. That's just me personally. And that's already in decimal. Convert that. That's already in decimal. And then take those decimals and place them in order. You can easily compare decimal numbers. It's easier to see which decimal number is bigger or smaller. So that's my recommendation for this one. Okay, so this is just asking, okay, which one's bigger, 2/19 or 9 1/2? This is interesting because, oops, there we go. You've got, this is what we call, I think they call this an improper fraction. I know it's kind of deceiving. I actually like improper fractions, although improper fractions make it sound like it's a bad thing. It's not bad to leave a fraction in improper form. And then this is what we call a mixed number. So both of these are going to have whole numbers and fractions involved, but I think the best thing to do would be to convert this. So I'll make one up. I'll do, so which one's bigger? I'll do 17 halves. Which one's bigger between these two? 17 halves or, I don't know. I'll make it up. 10 and a half. I'll just do that, okay? So what I'm going to do is I'm going to convert just one of these to either, so if I'm working with this one, I would convert either this one to mixed or I could convert this one to improper. Either way, I'd need to make sure I compare similarly. So I'm gonna convert this one to a mixed number. So you got to think, how many times does 2 go into 17? 2 goes into 17 evenly 8 times with 1 part left over. So what I've done here is I've just taken, I've basically did 17. I've done 2 divided by 7. I'm sorry, 17 divided by 2. So 2 goes into 17 8 times. Times that 16. You're left over with the 1, and then you know, you could put this in decimal form, and I can do that. I can put 0 here, bring 0 down. 2 goes into 10 5 times, and I'm done. But as you know, 8.5 or 8 5/10 is the same thing as 8 1/2. But what I did is I just took this remainder and thought, okay, that's the leftover remainder from the part of a whole. So that is 8 1/2. So which one's bigger, by the way, 8 1/2 or 10 1/2? In this case, in my example, 10 1/2 is bigger, so I would say 8 1/2 is less than 10 1/2. But you'll need to evaluate. I made my own up, so that's not the answer here. You'll need to evaluate your own, convert it either to mixed or improper, and then work with that. Final question, and this is a really important question. This says select the rational number that is equivalent to the term -2. And the reason we put this one in is because we need students to understand that integers can be written as fractions, and you need to understand how integers can be written as fractions. If you know how integers are written as fractions, then combining whole numbers with fractions, or multiplying or dividing or whatever is gonna be easier. So I'll make one up. This will be quick. I've already talked about this. So if I said -3, I don't know, make it up. -3. How can you write this as a fraction? Well, every integer can be written as a fraction because every integer has a denominator of 1. I know we don't usually write this. When I'm counting 1, 2, 3, 4, etc., I don't think 1 over 1, 2 over 1, 3 over 1, 4 over 1. I know we don't think that, but they're there. It's just that, what is 1 divided by 1? 1. What is 2 divided by 1? 2. What is 3 divided by 1? 4 divided by 1. Every single one of these divided by 1 is just itself. But we can use that to our advantage. We can use this knowledge to our advantage. So this right here would be, I'd rewrite this as -3 over 1. this would be the form or the fraction. This would be in a fraction form, rational number. So every integer is a rational number. Okay, I hope this is helpful for you, and good luck.